Okay, today we're working on the four big theorems. We're doing intermediate value theorem, mean value theorem, extreme value theorem, and average value theorem. You're almost guaranteed to get one of these as either a whole type FRQ or at least a portion of one or two of your problems in FRQ. All right, so the first question, we have a cylindrical can with radius 10 millimeters, and we're measuring rainfall in Stormville. The can is originally empty. That's important. We're starting with nothing, and then rain enters the can during a 60-day period. The height of the can is modeled by S, where S is measured in millimeters, and T is measured in days. Again, those days are only going from 0 to 60 because it was only measured for the 60-day period. The rate at which the height of the can or the height of the water is rising in the can is given by S prime. So notice that this is a derivative because we're talking about a rate. All right. So that's important to note that S is the height, um, whereas S prime is the rate. So according to the model, it says, what is the height of the can? Well, in order to get the height, which is S, we need to integrate S prime. And so since they want it for the 60-day period, we're going to integrate from 0 to 60 of that rate of H, or rate of the height, which is S prime of T, and we get 171.813 millimeters. The next question, or part B, says, according to the model, what is the average rate of change of the height of water in the can? So average rate of change, that's important. Average rate of change is like your old school average, like y2 minus y1 over x2 minus x1. So I'm going to do S of 60 minus S of 0 over 60 minus 0. Putting all that into my calculator, I get 2.864 millimeters per day. Notice here that I did give my units because they asked me to indicate units of measure. So if I hadn't given my units, I probably would have gotten a point taken off. Notice also that I'm not giving the points for this because comes from a practice exam. This is not an actual AP question. This was a practice exam, or from a practice exam a couple of years ago. All right, part C says, assuming that evaporation occurs, at which rate is the volume of the water changing at T equals 7? So first I'm going to start with my volume formula, again, using a little bit of geometry. Remember that volume is the area of the base times the height. So the area of the base, since we're talking about a cylindrical can, is a circle. So the area of the base is 100 pi, since the radius was 10. The height they told us the height was S of T. So that makes our volume equal to 100 pi times S of T. All right, so the rate of volume that they're asking for is the derivative of volume. So they're asking the derivative of our volume formula, which would be 100 pi S prime of T. And then plugging in 7, I have 100 pi S prime of 7. And then I literally plug that into my calculator. So 100 times pi, and then I plug 7 into my derivative formula that they gave us in the question prompt, and I get 602.218. All right, so that tells me that the volume of the water in the can is increasing at a rate of 602.218 millimeters cubed per day. Again, it's cubed because we are talking about volume. All right, question D says, during the 60-day period, we have Monsoon Mountain that accumulates in a can identical to the one in Stormville. The height of the water from Monsoon Mountain is modeled by this M of T, and M is measured in millimeters and T is measured in days, similar to that of Stormville. It says let D equal M prime minus S prime. Okay, and so D is basically talking about the difference in the rate of the water, right? The rate of the height of the water. And they said use the intermediate value theorem, which is really, really nice because they normally don't tell you to use it, right? You normally have to infer that on your own. But they said use the intermediate value theorem on the function d from 0 to 60 to justify that there exists a time t at which the height of the two cans are changing at the same rate. So basically, if the height of the two cans are changing at the same rate, we know that the difference between the two cans are 0. So what I did first was I checked D of 0. All right, and this is kind of like the technique or the tactic that you want to use to approach this. So I took my first endpoint, which was 0, and I checked what D of 0 was, and I got that it was negative 0.675. So again, I did n prime of 0 minus s prime of 0. I got negative 0.675. I know that that is a number that is less than 0. Then I checked my other endpoint, so D of 60. So I get n prime of 60 minus s prime of 60, and I get 69.3773, which is greater than 0. Again, that is a common tactic that you use to address these type of problems. You plug in your endpoints. Usually one will be less than 0, one will be greater than 0. So because D is continuous, the intermediate value theorem implies that there is a time at which the difference between n prime and s prime is 0. In other words, n prime and s prime are the same. And I know that because I know that D of t has to equal 0 somewhere in that interval, because 0 is between negative 0.675 and 69.3773. So I had to cross the axis at some point to go from negative to positive. So again, at that time, the water in 2 cans must be changing at the same rate because D equals 0 somewhere on the interval. All right, so a particle is moving on the x-axis, so its velocity at time t is given by this differentiable function, and they're showing us the function as a graph. The velocity is 0 at t equals 0, t equals 3, and t equals 5. They're just letting us know that's where it crosses the axis. They also tell us that the graph has horizontal tangents at t equals 1 and t equals 4. And then it says the areas of the regions bounded by the t-axis and the graph of V on the interval 0 to 3, 3 to 5, and 5 to 6 are 8, 3, and 2, respectively. So that means the first region is 8, second region is 3, and the next region is 2. At time t, the particle is at negative 2. All right, so the first question says, find both the time and the position of the particle when the particle is furthest to the left, and justify your answer. So furthest to the left, they're talking about the absolute most left. So they're talking about the extreme value theorem. All right, so since the velocity is less than 0 from 0 to 3 and 5 to 6, and the velocity is greater than 0 from 3 to 5, we only need to consider t equals 3 and t equals 6. So again, I'm starting at 0, and then I'm below the axis, so I'm going more left until I get to 3. All right, so 3 could be furthest left, but then at 3 I go a little bit right because I go above the axis until I get to 5, and then at 5 I go more left again all the way to 6. So again, 3 and 6 are the only viable choices because those are the places where I could be furthest left. All right, so what I'm going to do is I'm going to evaluate the function at 3. And so at 3, I know that I'm starting at negative 2 per the question. They said that at t equals 0, I start at negative 2. So to find x of 3, I start at negative 2 when I'm at 0, and then I'm going to integrate 0 to 3 of v of t. And so when I integrate that, again, I'm looking at the areas from 0 to 3 of this function. I'm getting that I'm at negative 2 minus 8. In other words, negative 8 was the region from 0 to 3, and it's negative because it's below the axis. So that x of 3, I'm getting negative 10. Next, I'm going to check x of 6. And so again, I'm starting at negative 2 at 0, and then I'm going to integrate from 0 to 6 of my velocity. So again, at that negative 2 is our start, and then from 0 to 3, we had negative 8. 3 to 5, we were at 3, and then 5 to 6, we were at negative 2 per the question. Add all that up, I get negative 9. So based on this, I'm furthest left, or most negative, at x of 3, which is negative 10. All right, now please understand that I did not really run the full extreme value theorem because it wasn't necessary. But when I taught you guys extreme value theorem, I taught you guys to check both endpoints and all their critical numbers. Therefore, you could have checked 0, 3, 5, and 6 because 0 and 6 are the endpoints. 3 and 5 are your critical numbers. You still would have gotten the same answer. It just was unnecessary and it wouldn't have been part of the points of the question. All right, so the next question says, how many values of t for t between 0 and 6 is x equal to -8? Notice they're not asking about derivatives or integrals or anything like that. That leads me to understand that they're asking me for the intermediate value theorem. They want to know where -8 falls on the original function, not on the derivative or anything like that. All right, so notice that this particle is moving continuously and monotonically. In other words, from 0 to 3, it's only decreasing because it's negative. So x of 0 is -2, and x of 3 is -10. All right, so from 0 to 3, I'm getting -2 to 10, and -8 does fall in that region. And then if I go from 3 to 5, it's also moving continuously and monotonically. It's only increasing because it's all above the x-axis. And so I'm going from x of 3 is -10 to x of 5 is -7. And then I can also look at from 5 to 6. Again, that's continuous. Monotonically is only decreasing. And x of 5 is -7. X of 6 is -9. So since -8 falls between -10 and -2, -8 also falls between -10 and -7. And -8 falls between -9 and -7. There are 3 values for which t equals -8. All right, part C says on the interval from 2 to 3, only from 2 to 3, is the speed of the particle increasing or decreasing? And be sure to give a reason for your answer. All right, so we learned in our last unit that the speed can be found by doing the dot product or multiplying your velocity times your acceleration. In this case, our velocity is negative at 2 to 3, from 2 to 3, and our acceleration is positive because it's increasing. All right, so if your dot product or your multiplication is greater than 0, we know it's increasing, and if our dot product is less than 0, is decreasing. So again, from 2 to 3, the velocity is less than 0 because it is below the x-axis, but the acceleration is greater than 0 because that velocity is increasing. So a negative number times a positive number is going to give us a negative number, which tells us that our dot product or our multiplication is less than 0, indicating that our... All right, so our last question for question 2 says, during what time intervals, if any, is the acceleration of the particle negative? Make sure you justify your answer. So here I'm seeing that, or I know from the Bible, that the acceleration of the particle is negative when the velocity is decreasing. And from the graph, I can tell that my acceleration is going to be less than 0 from 0 to 1 and 4 to 6 because my velocity is decreasing. All right, the wind chill is the temperature in degrees Fahrenheit a human feels based on the air temperature in degrees Fahrenheit and the wind velocity in miles per hour. If the air temperature is 32 degrees Fahrenheit, then the wind chill is given by W of V equals this function and is valid from V between 5 and 60. So the first question they want us to do, again with the calculator, is find our derivative of W at 20. All right, and then they want us to explain the meaning of what that means in terms of wind chill. So in my calculator, find W prime 20, I'm simply going to take the derivative of this function such that V equals 20. I'm literally typing it in just like this, and the calculator should spit out that I'm getting a wind chill, or a wind prime, or wind chill prime of 20 of -0.286. All right, so what that means is when my V, and again, V is simply your wind velocity. So when your wind velocity is 20 miles per hour, the wind chill is decreasing at a rate of, again, it's a rate because it's a derivative, a rate of 0.386 degrees Fahrenheit per miles per hour. Notice my units. All right, so it's change of y over change of x. Part B says find the average rate of change over the interval from 5 to 60. Again, average rate of change is simply your y2 minus y1 over x2 minus x1. And then it says find the value of v at which the instantaneous rate of change, so the derivative of a w, is equal to the average rate of change. Anytime they're talking about instantaneous rate of change equaling your average rate of change, you know they're talking about the mean value theorem. All right, so let's start with our average rate of change. So I'm going to do W of 60 minus W of 5 over 60 minus 5. Literally just plugging that straight into my calculator, I get negative 0.253. Then I want to know where my derivative, so I'm literally going to say derivative of my W equals that average rate of change. And I'm going to do that as a solve in my calculator, and I get that V equals 23.011. Again, they didn't ask me for units, so I'm going to leave it like that. I'm not going to be too extra. Part C says over the interval from 0 to 4 hours, the air temperature is at a constant 32 degrees Fahrenheit. So the second I see it's at a constant 32 degrees Fahrenheit, I'm thinking some type of linear type function because it's not, the rate is not changing. At time t equals 0, the wind velocity is v equals 20 miles per hour. If the velocity is increasing at a constant rate of 5 miles per hour, again, very constant, very linear, what is the rate of change of the wind chill with respect to time at t equals 3? All right, so there's a lot going on, but I do notice they're talking about respect to time, and we're using a bunch of different variables. So I'm feeling like this is a related rate. So I'm just going to start going with my no find wind. So I know that dv over dt, they told me that that was 5 miles per hour per hour. All right, that was given to me right in the problem. And they told me that that was a constant. They're asking me to find dWdt because they said, what's the rate of the wind chill with respect to time? And they said wind t equals 3. But they also told me that the velocity, or the wind velocity, is 20 miles per hour and is changing at a constant rate of 5 miles per hour. So I'm going to do 20 plus 3 times 5. And again, I'm using 3 because I'm looking at t equals 3, so that's 3 hours later. And so for every 3 hours, it's changing by 5 miles per hour. And so 20 plus 3 times 5 is 35. All right, so working with this out, I'm going to start with my formula for W. And then I'm going to take my derivative with respect to time. So dw dt equals my derivative. And then I'm going to plug in everything that I know. So dw dt is that derivative times dv dt, which we know is 5. I'm going to plug that whole thing into my calculator, and I get dw dt equals negative 0.892 degrees Fahrenheit per hour.